Sketch the graph of the polynomial function p of x equals x cubed minus 3x squared. The first thing we do is we look at our leading term, which is right here, and we use the leading coefficient and the degree to determine our end behavior. So we have our leading coefficient, which is the number in front, which is just 1, okay, which is positive. And a positive leading coefficient means that y approaches infinity as x approaches infinity. And then we use the degree, which in this case is 3, and that is an odd number. And when your degree is odd, that means that your end behavior on the left side will be different than what it was on the right. So this means that since the right side was going up, the left side will be going down. So y approaches negative infinity as x approaches negative infinity. Okay, then after our leading term gives us all of that information, we're ready to factor our polynomial. So if we factor this, we can factor an x squared out of x squared times x minus 3. And from this we determine our zeros. Our zeros, we've got x equals 0, and that has a multiplicity of 2. I'll just put that in parentheses so remember that. And we have x equals 3. And the exponent on that is 1, so that's a multiplicity of 1. Okay. Then we draw our end behavior. So here we have on the right side, we're going up. So we know that we're going to have a arrow going up over here on the right. And here we have on the left side that we're going down. So we've got an arrow coming down here. Then we can plot our zeros. We've got a 0 at x equals 0 and at x equals 3. And then we just connect our end behaviors to that to those points using the proper behavior. So at 0, we have a multiplicity of 2. That means we're looking like x squared, which is a parabola. So when I connect my end behavior to that point, I need to look like a parabola. So I look, just kind of like bounce off, that kind of looks like a parabola. Okay. At 3, I have a multiplicity of 1. So it's going to look like x to the 1, which is just a line. And so I just cross through like a line. Okay. Now obviously this is not super pretty. It's probably something more like, nice and skinny and then something like that. But this is the general idea of what we're looking for. So we connect our end behavior to our zeros. And that's a sketch of our graph.